We've collected data as to how many hours each member in a school jazz band on average is practicing. We've put that data into our calculator and determined what is the mean and what is the standard deviation. And even though it doesn't tell me it's normally distributed, I'm kind of assuming that it is in this case, which could be dangerous. But I've drawn a bell curve. I've indicated this is the mean. I've added 1, 2, 3 standard deviations, and I've subtracted 1, 2, 3 standard deviations. I'm ultimately trying to determine what percent of the band on average is practicing more than Alexis. I know that Alexis on average practices 22 hours a week. On the x-axis here, this is the number of hours that they're practicing. So I know that 22 is going to be between 20.7 and 24.9, and it's about in the middle. So I put Alexis here in the middle, and I've shaded more than that many hours. Now I know from what I know about a bell curve that 2.5% of the data is from this standard deviation to the end, but I don't exactly know what percent of the data is going to be in here. I know this section is 13.5%, but I cannot cut that in half because if you look at this, this is the area under the curve, and clearly this is a larger area than this is. So do not just cut it in half. That's not going to work. We're going to need another strategy. I heard some of you saying, let's calculate a z-score. So let's try that because we do know the mean, the standard deviation, as well as Alexis's value. So I've substituted those into my formula. And remember, we're always rounding to the nearest hundredth. So my z-score is 1.31. Now we know that that's going to fall between 1 and 2 standard deviations above the mean. So if you look at where Alexis falls, that number makes sense. You can always check to see are the values reasonable. But we still don't know what percent of the data exactly is going to be above because we're not falling right on those 1, 2, or 3 standard deviations. But we can use the z-score in conjunction with a new strategy we're going to use today to get the exact percentage. We already know the percent of data approximately that lies between different standard deviations on the bell curve if our data is normally distributed. If the value that we have does not lie exactly on 1, 2, or 3 standard deviations, either above or below the mean, we can calculate a z-score, and then we're going to use a z-score table to determine the percentage that is to the left of value. Now you have a z-score table in the back of your textbook, so I'm going to get you to go grab your textbook, and then if you go into the back, page 580, you're going to see your z-score table there. Let's say that we calculated a z-score value of negative 2.76. The way that you read this is you go down the column to find to the nearest tenth. So I'm going to be looking for negative 2.7. So I'm going to go down here. There's negative 2.7. And then the 100th position is listed across the top here. So one of my fingers is going to go down to negative 2.7. The other finger is going to go across the top to 6/100ths. Where those two column and row meet, that is the percent of data to the left of this z-score. Now, instead of writing it as a percentage, they write it as a decimal, but we can multiply all of these values by 100 to get the percentage. So I know that 0.29% of the data is to the left. And then knowing what we know about a bell curve, take a look. We know that usually 0.15% of the data is to the left. Because we have a little bit more included there, that value makes sense. Okay, this is somewhat tricky to do here, but I want you to notice that negative 2.99, that is almost at that negative 3 standard deviations. And then as we run along this table here, the numbers are going to be getting larger and larger. On the left-hand side, these are all of our negative z-scores. So negative 0.00, this last box here, that is 50%, 0.5. So I know half of my data is to the left of a mean of 0. If we move to the next page, on the right-hand side of your textbook, these are all of our positive z-scores. And again, you can see that they're going in order from smallest to largest. So there's a difference across the top. On the previous one, we started with 0.09. Now we start with 0.0 and they move up because we're always increasing. So just be aware of that. If I go to my final cell here, this is 2.9 and again 9. So almost 100% of my data is to the left of that point. Now, we do in theory have some more that extends beyond 3 standard deviations, but the majority is going to be under that curve. So we are increasing as we move from left to right. You can see that those percentages are getting increasingly bigger. If I have a z-score of 0.35, what percent of the data is to the left of 0.35? Hopefully, you came up with 63.68%. One of your fingers runs down to the 10th, 0.3. The other finger runs across the table to the 100th, 0.05. And where your two fingers intersect, that's the percent of data to the left. So 63.68%. We know that 100% of the data is represented beneath the bell curve. Always shade the area of the curve that we're looking at. It's going to help you realize whether or not your value makes sense. I'm given a z-score in the first example of negative 2.15, and I'm looking for the percent of the area below that z-score. So this is when z is less than this value. So I'm going to find negative 2.15 is going to be between negative 2 and negative 3, so approximately there. And I'm looking for the percent of data to the left of that. In your z-score table, you're going to go down negative 2.1 across to that 5/100ths, and you should see that as a percentage, 1.58% of the data is to the left of that. Now, your z-score table always gives percent of data to the left. In the second example, we're trying to figure out what percent of data is to the right of this negative 2.15. We're looking at the area of the curve where it is greater than negative 2.15. The table in the back doesn't tell me that, but it will tell me the percent of data to the left, which we already established was 1.58%. So if I know that I have 1.58% of the data to the left, I can subtract that from 100 to get the percent of data to the right. And then I want you to take a look at this last one. Pause the video and see if you can figure out what percent of the data is between those two values. And again, you're always checking the bell curve to see if this makes sense. I know this is 50% of my data to the right of the mean. I know this is another 34%. This is another 13.5% plus a little bit more gives me that 98.42%. And then with the last one, we're looking at what percent of the data is between negative 2.15 and positive 2.15. Now, we already established that the percent of data to the left of that negative 2.15 is the 1.58%. So I know to the left of that, this part that's not shaded, that's 1.58% of my curve. I can use my z-score table to look up what percent of the data is less than 2.15 because the z-score table does give me that data to the left. So if I do that, I can see on my z-score table that 98.42% of the data is less than 2.15. So what I want to do is take this percentage, remove the part that is not shaded, and that gives us 96.84% of the data in between those two values. Again, make sure that makes sense. This is not the only way you can go about this. Some people recognizing that these are just absolute values of one another know because your curve is symmetrical that the area represented here will be the same as the area represented here. So some people just like to double this amount and subtract it from 100% of the area. There's more than one way you can go about this, but you all should have come up with the same value. We can also use our z-score table to do the opposite. So in these two examples, we're given the percent of the area that this curve represents, and we are asked to determine the z-score. Because our z-score table uses the decimal values, I've changed this 17.62% into a decimal, and I'm going to go through that middle part of the table and find the z-score that most closely corresponds to that value. Because I was below the mean, I know my z-score is going to be negative. I also know that those numbers go in order. So I'm looking for that 0.1762. So we've got 0.0, 0.1 starts around here. So I keep moving through the table until I get to that number. Now, your number might not always be there because as you can see, there's numbers in between here that are missing. You need to go to the closest one. So this one happens to be exactly on here. So the percent of the data to the left of that z-score, and that z-score is, I'm going to run over here, negative 0.9, and then I'm going to run up here, 0.03. So my z-score becomes negative 0.93. Now in our next example, we're told that the area to the right of this particular z-score is 14.92%, but in my z-score table, I'm only ever given the data to the left of a particular z-score. But knowing that 100% of the data is below that curve, if there's 14.92% to the right, subtract that from 100 and that gives it 85.08%. The data to the left. Now, as a decimal, I'm going to look in my z-score table for the z-score most closely corresponding to that percentage. Because we're on the right-hand side, I know my z-score is going to be positive. So again, these numbers go in order. So here's the 60%, 70%, 80%, and I want 85.08%. Now again, it may not be there, but this one happens to be there. Otherwise, go with the closest one. The z-score corresponding to that number is going to be 1.04. 1.04. In our next example, we're trying to find this z-score, and again, our z-score table will only give us the data, percent of data to the left of that. I know that this shaded region is 25.8% of my data, but I also know if this is the mean, there's 50% of the data to the left of the mean. So what we can do is say, okay, if this is going to be 50% of my data, add those two together, and I'm going to be looking up 75.8% in that table. There it is. So the z-score corresponding to that is 0.70. And in our final one, we have to find two z-scores, z-score 1 and z-score 2. We know that there's 21.45% of our data in this shaded region. We also know that in this blank region, we have 12.92% of the data, and 0 is where the mean is. So that also tells us we have 50% of the data to the left of that. I want you to think about how you could go about getting those two z-score values. Pause the video and try to work that one out. Okay, beginning with z-score 1. If I know there's 50% of the data to the left, take off this piece, take off this piece, and that tells me that there's going to be 15.63% of the data to the left of z-score 1. So I can use my z-score table to look up the number closest to that to get that z-score. 15.63% is not exactly on here, but I know it's going to lie between those two values. I also know it's going to be on the negative side of the z-score table because I'm below the mean. The closest number is this one. We're only going to be 1/100th% under versus this many hundredths of a percent over. So I'm going to use this. It's my closest value. So we're going to go over here, and the z-score that corresponds is -1.01. Now I'm going to look for z-score number 2. Because the table of values will only give me data to the left, I need to know how much data is to the left of that. So I'm going to add those two together, this region and this region, and I know 37.08% of the data lies to the left of that. 0.3708 is not on here, but it's going to be between these two numbers, closer to this one. So the z-score that corresponds is -0.33. And then always make sure that you verify those values. So if this is 0, we know the x-axis is a number line. This number is going to be closer to 0 than this is, and that is in fact the case. So if there's any mistakes, hopefully you can catch it. Now I'm going to put all of our skills together and try to solve a problem. In this particular question, we have a muffler company, and they've gathered data based on how long a muffler is going to last. It tells us that the data is normally distributed, and if it tells you it's normally distributed, you know the first thing to do is to draw that bell curve out. And then you want to shade on the graph, are we to the left or to the right of the value that we're given? In this particular question, we want to know what percent of mufflers would we predict that would last less than 6.5 years. Oftentimes, this is all you'll get. You're not going to see step by step, draw the bell curve, do this, do this. You have to know how do we set this up and then where do we go with that. So the first thing we're going to do is set up our bell curve. And 6.5 years is going to be in between 5.4 and 7.2. So about there, we're looking for the percent of cars that are going to last less than that number of years. Because it doesn't fall exactly on 1, 2, or 3 standard deviations, that tells me I need to calculate my z-score. So I recognize I need to do that. And again, watch your rounding. Here's a case, if you look up negative 0.38 in the table, you're going to get the wrong percentage. So you have to follow your rounding rules to 2 decimal places. The z-score corresponding to this is negative 0.39. And again, look at this. If we standardize this to a mean of 0 and a standard deviation of 1, this is negative 1. We should be between 0 and negative 1, closer to this side. So that z-score is most likely right. Now you're going to look up what is the percent of data to the left of this number, and that's good news for us because our z-score table always gives us data to the left. We should have got 34.83% of the data, and then take a look, does that correspond to what we know about a bell curve? In this course on a summative assessment, you will be expected to go through the detailed process of how you generate that percentage, but there is a way you could check on your graphing calculator to see if you're close. Taking that same muffler question, you have a normal cumulative distribution function in this particular menu on your calculator. If you have a TI-83 calculator, you're not going to have all of the prompts. If you have a TI-84, it will kind of prompt you. So we're looking at what is the probability that our muffler is going to last between 0 and 6.5 years. On a TI-84 Plus calculator, you're going to see a menu with these categories listed for you where you can just enter our minimum value is the 0, our maximum value is the 6.5. So we're looking at what percent of the data would be in between those two, given our mean and our standard deviation. Now, if you have a calculator that it already has these programmed in there, you're going to notice it won't say 0. It's going to have a scientific notation there very close to 0 because remember, in theory, on a bell curve, we can continue on to negative infinity. Okay, so we're going to go second function, and we're going to go into the vars menu to get that distribution. We're going to choose number 2, and we're going to enter our minimum value, comma, our maximum value, comma, the mean that we've calculated or that's given to us in this question, comma, and the standard deviation. We're going to close the bracket and we're going to press enter. And then as a percentage, this is 34.86%. It's not exactly the same as what we calculated by hand. The calculator is actually more accurate because our z-score table doesn't have every single value in it, but you would be very close. On the TI-84 Plus calculator, you can see when we go in here, second function, vars, number 2, see how that's very close to 0. And we're going to put our upper bound value, so the maximum range that we're looking at is that 6.5. The mean that they've given us, we're going to put in here 7.2. And the standard deviation we have is 1.8. And then we're going to press enter, enter, enter. And it's going to give us that percentage once again.